everybody. Yeah, so this is a story about curiosity and how Greg really inspired a lot of curiosity in me scientifically, and obviously a lot of other people here today who have given some excellent presentations so far. So, I started out as a wildlife biologist working on large terrestrial mammals throughout the state of Alaska, and then in 2014, I was hired as a wildlife research biologist for the Department of Fish and Game. And my job was to investigate predator-prey interactions in Southeast Alaska, and I was looking for a project. And so I started talking to people who are really familiar with the issues, and that's how I first got to know Greg. And one of the issues that really piqued his interest was the recent colonization of wolves to Pleasant Island. And this conundrum was eloquently described in the Strawberry Point News, penned by Greg and Tanya Lewis. They described the arrival of wolves in 2013, and that these wolves discovered the ultimate cornucopia of carnivore delights, a small 50 square kilometer island with abundant deer estimated at between 120 and 200 deer. But by 2015, the deer pellet transect surveys conducted by Fish and Game suggested a 72% drop in the population. Right, so of concern was that the alternate prey, for example, moose on the mainland, could keep the wolf population high. And despite the absence of primary prey, in this case deer, this could cause the deer to go into what is known as a predator pit. So Greg thought that the classic Coronation Island study could give us a clue as to what could happen next on Pleasant Island. Coronation Island is in Southeast Alaska, and it's similar in size to Pleasant Island, so this is a good comparison. Before 1960, it had an abundant deer population close to carrying capacity. So this figure shows a simplified food web over there on the left, and then population trends on the right with deer in the red and wolves in the blue. So you can see deer were high at this time. And then in this experiment, 4 wolves were transplanted to Coronation Island in 1960 to measure the effects of wolf predation on deer. And within 4 years, the wolf population had increased to 13, while the deer declined dramatically. Foreshadowing the trends of Pleasant Island, the wolves then switched from deer to marine resources, and then eventually began eating each other. There was 1 wolf left by 1968, and eventually the deer rebounded. And from this experiment, it was concluded that on small and isolated islands, deer cannot survive in the presence of wolves. And furthermore, once all the ungulates are gone, wolves can't survive either. From this research, a lot of the wolf population models that came after really assumed that wolves are only reliably found on big islands or on the mainland, and that it's the ungulates that really drive wolf densities. So the big question was, could this also happen on Pleasant Island? So I was egged on by Greg, and to help me jumpstart this project, he drove me over to Pleasant Island in late October 2017 in his skiff, and he deposited me at Bull Moose Cove. And before he departed, leaving me alone for a few days, he provided me encouragement to just look around and take copious notes. So I walked many miles in those first few days, which over the years has turned into 1,000 miles. And that October, I found many sets of wolf tracks, as you can see here, and lots of wolf scat, which I collected in Ziplocs. And I also found scattered piles of deer hair and bone shards, showing that a wolf pack had become established and was preying on the island deer, just as all the people in Gustavus already knew. So that trip really marked the beginning of a long-term effort to collect data on wolf diet trends and estimate the pack size on Pleasant Island and quantify the impacts of wolf predation on the island deer. And serendipitously, I had just recently begun working with Dr. Tal Levi at Oregon State University, where he had set up a lab to apply innovative genetic methods to studying wildlife. And together we were conducting a large-scale diet survey of wolves throughout Southeast Alaska using fecal metabarcoding. And this is a technique that uses DNA from the wolf scat to identify prey species. So here we are last summer looking for wolf poop on Pleasant Island. So wolf poop had become one of the most valuable currencies to understanding the diet patterns of this cryptic predator, and it was so valuable that we started calling it brown gold. And Greg knew this, so he embarked on a 6-day expedition to Pleasant Island with Judy and Kathy and friends in the spring of 2018. And an email arrives in my inbox, and I read, "Tomorrow, your fondest dream will be realized. A bucket of poop, prepaid, coming in on seaplanes." And this was indeed my fondest dream. 55 bull scats, that was a windfall. So, and this story was featured on Alaska Public Media in April 2018. Greg described that most of these wolf scats contain sea otter. And they had also found 5 sea otter carcasses ranging from old to fresh. Greg went on to say that no deer were seen at that time, and that the deer trails are just revegetating ghosts. Only a few scats contain deer hair, hinting at an abrupt switch in the diet patterns of these wolves. In summary, Greg wrote, "Wolves may have eaten themselves out of groceries and mostly died or left. And the island is a different place than it was a decade ago." So that bucket of poop was really a turning point for this study. Meanwhile, I and my team, we've been collecting wolf scat throughout Southeast Alaska, and the metabarcoding results had come in. So we had collected 860 wolf scats over 8 years and identified 55 diet items, including ungulates, fish, birds, small mammals. And what we learned is that here in this area, Gus Davis and Pleasant Island, wolves also ate a lot of marine mammals, especially sea otters. So focusing in now on Pleasant Island, we used 2 complementary methods to profile the wolf diet patterns over time. And the fecal barcoding analyses show that in 2015, deer were the primary diet item, but in 2017, there was a shift. Pleasant Island wolves started eating mostly sea otter. Stable isotope analysis of carbon and nitrogen ratios of wolf hair really showed the same shift from deer in 2015 and 16 to marine resources by 2017. So the wolves switched their prey. And as we know, this dietary shift of wolves coincided with a big decline in deer abundance. So this red line here shows the time when wolves first colonized the island in 2013, and then shortly thereafter, no deer pellets were found in 2018 or 2020 during the pellet surveys. So we also use GPS collared wolf locations to identify kill sites, and we found 38 sea otters killed by wolves along with 12 scavenged sea otters, and we estimated that each Pleasant Island wolf can eat between 5 and 13 sea otters per year, and that's based on body size and consumption rate, and our kill site data really corroborated that as well. So we considered it a definitive predation site when we found fresh blood or signs of hemorrhaging or even drag marks leading from the ocean. And we've learned from these GPS-collared wolves and from one very lucky observation that wolves ambush sea otters when they haul out on land or when they're in shallow water. Sea otters do haul out on rocks to conserve energy from time to time. However, this does increase their vulnerability to predation. Wolves are often seen on Pleasant Island patrolling the shoreline and investigating these rocky outcrops. So we thought this behavior might be unique, but instead we've also learned that in Gus Davis this is also happening. So this trail camera series shows a wolf dragging a sea otter to shore. From tracking GPS-collared wolves, we've seen an increase in kill sites of sea otters over time, including in the year summer 2022, 26 sea otters killed by wolves alone. You know, so what is the significance of this behavior? Throughout the world, wolves really rely primarily on terrestrial prey, and this relationship is very well established. So wolves are very strongly linked to terrestrial systems. However, wolves are famous for their dietary flexibility, and they consume many marine species. And this really can give them a leg up when there's declines in their primary prey. And the Pleasant Island wolves really took this to an extreme. So marine subsidies can tip the balance, and it can alter terrestrial predator-prey dynamics. So going back to the Coronation Island example, we saw wolves couldn't exist without deer. But in contrast, on Pleasant Island, wolves have remained 8 years after eating all the deer. So why the different outcomes? One idea is that Pleasant Island wolves do have sea otters as food, but the Coronation Island experiment happened before sea otters had recovered. Another idea is that sea otters are consistently available as food year-round, whereas other species like salmon are only available seasonally. So this is what allowed wolves to persist at high densities despite the declining deer, and put more pressure on the deer, ultimately wiping them out on Pleasant Island. We've been expanding our research into other areas, and we've learned that where sea otters have recovered, wolves are able to learn how to kill and eat them. And these red dots on the map show places where we have found wolf scats with sea otter in them. So a couple different studies, one led by Ellen Dimmitt in the Alaska Peninsula. She's found that sea otters make up 18% of the prey of wolves in Katmai National Park. Study that Tanya Lewis already described, she's leading the charge here, has found similar results. And another PhD student, Kayla Fratt, is working on the islands of Q and also Prince of Wales Island with dogs to help find the scat. So in summary, using marine sources, this is a strategy that allows the wolves greater ecological flexibility and enables them to adapt to changes in the environment, like declining prey, and this really highlights the remarkable resilience of wolves. So thanks to Greg for inspiring the study, and thank you for your attention.